Alright, now that we have the ability to save out and reload node networks, it's time to take all of the things we built so far and put them to work. In the next series of videos, we are going to be assembling a mock game demo. We're going to put together a series of classes to represent a player, an actor, and a health pickup. And we are going to set up a scenario that will allow us to build and utilize a custom node network for our enemy's navigation. So the purpose of these videos is to see a real-world example of the principles we have learned so far. Now in this video we're going to do some basic setup, management, and just get the project ready to go for our new game demo. So what we'll be looking at is bringing in a few new texture assets. We're going to set up these texture assets, one of them being a new game background. In order to demo this kind of gameplay, what we've put together is a simple background screenshot of an actual game. Now we're not going to take this all the way into a full game design series where we're not going to cover things like how to do collisions and things like that. Again, we want to stay focused on AI navigation. So we have a background level put together that has some walls in place, and the idea is we will build a node network around these walls so that when an enemy is moving around the level, he will visually move in the correct ways and not navigate through walls. Now to get started, we're going to bring in some new texture assets. Over here, I have a new background file and a health graphic. We should be able to take a quick look at the background itself, and we can see here that this is a simple layout of 4 different angled walls. The idea with this layout was to give the concept of different rooms while still having walkways that interconnect, and also not setting up a scenario that's too complicated to do at an 800 by 600 resolution. So again, the idea is that we will set up a series of nodes to allow an enemy to navigate past all of these walls. We also have a health graphic that we're going to use for the enemy's health power-up. I would load it up, but this health graphic is designed as a white graphic with a transparent background, and as we can see in the thumbnail down here, that looks like a pure white square. So again, that's just a cross-shaped icon that we are going to colorize and draw inside of the game. So now that we know that we need these 2 new assets to be drawn, we're going to drag both of these into our project in the Solution Explorer. We're going to drop them onto Content in order to make sure that they both get imported. So there we have our background and our health. Now we're going to turn our attention to the Style class so we can set up some fields in order to hold these texture asset references. So we're going to jump down here in our code and we will locate the Style class. Inside of Style, we'll scroll down until we see the node texture. Now, just to keep things quick here, I'm going to copy and duplicate the node texture line, and we will change the name to health texture. We need one more texture for the background texture, so I will duplicate this line again and change the name to background texture. Alright, that gives us 2 new texture references that we can use. We need to now turn around and make sure we load in the texture asset as soon as our game loads up. So now we'll move down to the load content method, and once again I'll begin by duplicating the node texture line. Here we've duplicated the line where we are loading in one of our texture assets. We'll change the name of the reference that we're loading first to health texture, and into the health texture reference we will load in the asset named health. Then once again we can duplicate this line, changing the name to background texture, and changing the asset name to background. Alright, that takes care of the new textures for our game. The next thing we need to do is we need to set up our node editor, our path node editor, so that we can see this background graphic while we're placing nodes. Of course, since we need to see what it is we're working on. So now we'll change our attention to the Scene Editor class. Inside of Scene Editor, of course, we have all of our code that is allowing us to place and work with path nodes. If we scroll through this code to the very bottom, we have our draw method, and we'll jump in right before we draw our text, and we'll put together a drawing line that will draw our background texture. This line will start as spritebatch.draw. We will draw the texture found in Style as the background texture. we'll position this texture at 0, 0, so we'll specify vector2.0. We'll draw the texture with the color of white, since we don't wish to modulate any of the colors in the texture itself. Alright, that takes care of our sprite batch draw line. Now we can briefly jump into the game and test and see what things look like, though we may run into some issues with drawing order. But let's now build and run the game. So our new texture gets built in. We now see the texture getting drawn inside of our game, but you'll notice we have some interesting things going on with our text. The word mode has the first letter chopped off. And if we start to place path nodes, you'll notice sometimes the lines draw and sometimes they don't. The problem is we've defined the line layer to be draw layer 0, and we're also drawing our texture at layer 0. So this is causing some fighting between that layer since we have pixels that exist at the exact same layer depth. To correct this, we're going to slightly adjust our line layer depth back in style. We're going to scroll up where line layer was originally the lowest. We're going to bump this up a little bit to 0.1, and that will bring line layer up off of the ground. The other thing we'll need to do is to bring our text forward a little bit. Now we don't have a layer defined here specifically for the text as in our HUD text. Text layer was being used for the numeric information associated with nodes. So inside of our scene editor, what we'll do is we'll simply drop in one of the overloads to drawstring that will let us gain access to layer depth. So let's move here to our first drawstring line and assign some further parameters after the color. What we'll do is we'll drop in a rotation, we'll drop in an origin of vector2.0, we'll drop in a scale of 1, sprite effects of none, and finally that will allow us to access the layer depth parameter, which we will set to 1. Alright, the next thing we'll do is we'll take our second line that's describing how to begin navigation. We'll comment this line out for now because we want as much screen space viewable for the placing of actual nodes. So now if we run, we can see all of the letters in mode are drawing properly, and if we draw out various nodes, we can see that none of the lines disappear as we're drawing out nodes. Now, one more thing we're going to tweak with our graphics before we move on is the fact that our new level background uses grays for some of the level textures, and our nodes are connected with lines that are also gray. This makes it very hard to see the node lines in certain scenarios. To make it easier to see these lines as we're working with them, we're going to bump up the brightness of our line colors. So back in style, we're going to change our line color setting from a value of 80 gray to 180 gray. So that's 180 for all of the color components. Now if we drag out some nodes, we can see we have some bright, almost white colored lines between the nodes themselves, which will work great for placing them. Towards the end of the video, we could always readjust these back to a darker color when we need to look at how paths are actually solving. But with these things in place now, we have our visuals set up. So now we can move through a level and draw out all of our path nodes. Now, before we get into building the path node network itself, there is one final adjustment, so a little bit of reorganization that we're going to do to our node class. At the moment, our scene editor has a handful of methods towards the bottom, things like getRandomNode, navigateToNode, and getClosestNode. Now, some of these methods, we're going to need access to these methods when we're building our new game. We're going to use the same principles of needing to find actors based on the node network. So we're going to need the methods getClosestNode and getRandomNode. But you'll notice that first, these methods are private to the scene editor, so we can't get to them from anywhere from the scene editor. We know that we're about to need to access them from two different classes. Of course, in scene editor, we'll still need to use these, so we need to come up with a good centralized location to put these methods. What we're going to do is we will redefine these methods as static methods that are part of the node class. Again, since both of these methods are node-centric in nature, they both revolve around the operation of nodes, we'll move them to the node class. We'll begin with getClosestNode. We'll take the whole method and simply cut it out of the scene editor. Now we need to bring up our node class, and inside of node, we'll scroll all the way to the bottom of the class. Right here after our method, you can see that the last method here is our draw method. will drop in right below this method, and we will paste in the getClosestNode method. Now we need to change this method since, again, we want it to be both public, so it's externally accessible. We're also going to set it to static so that we don't need a node reference in order to use the method. So this is going to be a public static method returning a node called getClosestNode. Alright, you'll notice we now have some errors listed at the bottom since Scene Editor is trying to get to its method that no longer exists. We'll address these methods and clean everything up after we move our final method over. This last method we're going to readjust is getRandomNode. We will need access to this method as well when we're building our game. So let's grab it and move it out of the Scene Editor, jump over to the node class, and paste it in right below the getClosestNode method. Once again, we'll change the method to be a public method that is static. So public static node getRandomNode. Now there is another thing we'll need to adjust in order for this method to function. When the method was placed in Scene Editor, it relied on the fact that the Scene Editor had a random object stored inside of it. Here this isn't the case inside of Node, and we don't want to store a random object statically inside of Node, since the user of this method may want more control over how the random object is working. For example, setting a specific seed. So in order to retain flexibility when using this method, we're going to change the method so that it requires a random object to be passed in before it hands back a random node. That way the user of this method is responsible for managing their own random object. So we'll make a random parameter called random. So we'll pass a random object in that satisfies the name random for the code itself. And we can still use this code directly from things like the Scene Editor, since it already has the random object that was originally created for this purpose. Alright, this takes care of the brief reorganization that we need to accomplish. Let's finish things off by readjusting our Scene Editor to point to the correct locations of these new methods. Back in Scene Editor, we can actually jump through the error list one by one to simply jump to the places that require adjustment. The first of these is going to be inside of the goal-reached handler inside of Scene Editor. It's here that we're picking a new node to begin navigating to. So first off, we're needing to gain access to the getClosestNode method. This is now housed in Node, so we change the name here to node.getClosestNode. Now we can move on to getRandomNode. Once again, this is node.getRandomNode, but in this case, getRandomNode requires a random parameter. So we will pass in the random field currently stored inside of the Scene Editor. That takes care of both of these instances and leaves two more cases where getClosestNode is in use. Let's jump down to the next one, which happens to be inside of our keyboard handling. Towards the end of the keyboard handling section, when we press the Enter key, we once again need to find the closest node to our AI actor. We can quickly patch this up by saying node.getClosestNode. That leaves us with our final access, which is here under the mouse move section. One last time, we'll change the method to node.getClosestNode. That cleans up all of our remaining errors. And if we jump in and run the game, we can see that we can now click out a series of nodes, and all of our code is functioning just fine. Alright, so with this, we have kicked off the project for our game. We've got our new texture assets loaded and ready to go. We've got our graphic drawing in the background ready to be path noded out. And we have readjusted the code to make it more modular so that we can go forward with the creation of our game. So that is going to wrap up this video.